So I decided to do this top 150 interview questions from today. So let's see. This is the first question in that list, and we basically need to merge two arrays which are already sorted into a one big sorted array with the elements from both of these given arrays, nums1 and nums2. So and we have to return nums1. We don't have to return nums1, we just have to update nums1 with the final sorted array, and they will compare if it is sorted or not. So first let's try to do it the easy way. We'll have another array out. We'll have another array out, and it is going to be an array of int of an empty size initially. So while when there is no while in a Golang, it's just for m and n, right? For m less than okay, so I'll have like two pointers, p1 and p2. They both will start at 0. So I will check for p1 is less than m. As long as this is true, as long as p1 is less than m, or p2 is less than n, as long as this is true, I will keep doing this what do you say, I'll keep doing what I have to do in this loop. Sorry for my communications gap. So whatever. So as long as p1 is less than m and p2 is less than n, what I am going to do is I will check again if so I will have like two conditions, right? If so I will actually have a AND condition here because I don't want to have a duplicate loops inside. So as long as both of those pointers are within the range, what I will do is I will update nums at if nums1 at p1 is less than nums2 at p2. If that is true, then I will have nums1 at nums1 at p1 is equals to, I will have nums1 at p1, and I will only increase p1 because that is handled, taken care. In the else case, I will have nums out at p1 plus p2 is equals to nums2 at p2, nums2 at p2, and I will increase p2 value. So then again I will have a condition here for as long as p1 less than m. As long as this is true, out at p1 plus p2 no, actually I don't want out is equals to append of out and nums at p1 plus plus. Even here I should not be doing this. Instead I should be doing out is equals to append of out and nums1 at p1. Likewise I will be doing nums2 at p2, and I will increase out. And likewise I will have another condition down here, which will basically do as long as p2 is less than n. So as long as that is true, I will be should be nums1 here, and it should be nums2 and p2, and likewise here p2. So once that is done, for element for element in range out, I'm just looping through our final array and updating nums1 because they want the solution to be nums1. We'll update this solution if we'll try to update this solution, so we update the nums1 array itself, but for now let's update like this. So as long as that is true, I want this idx value as well. So nums1 at idx is equals to element, and we don't have to return anything. So let's see if this works or not. Expects to found one. Think is the solution. Okay, this is working. Yeah, this worked, but to be honest, this is like kind of like a brute force solution. It's not a brute force solution, but we can actually optimize this a bit so that we don't need a out array. We should be able to update nums1 array directly. But in order to do that, what can we do is let's think. Nums1, the problem that I have right now is maybe like I can start updating nums1 from the end, or do you think that will work? So let's say my current pointer is here, and I'll check at this position 3 and 6, which should be here. It should be 6, right? So 6 will go here, and then I will move this pointer to 5, and the p1 will stay at 3. Now I will compare 5, so I will decrease p2 and update this 5 here, and it will be 2. Likewise I will update 3 or 2, so it should be 3 this time. So it will go 3 will go here, and I will my pointer will be 2 and 2, and it doesn't matter, so I will just update and 2, and it also doesn't matter, and finally it will be 1. I'm not sure if that will work or not. What if I have all the lesser values? By the time I come here, I should have at least used up these ones, or I should have used up these values. If I have used up these values, then it's all right, correct? These will stay 3 and let's say 3. But let's give it a try. I will show you what I was talking about. So p1 and p1 will start at m minus 1, and p2 will start at n minus 1. As long as p1 and p2 are greater than or equals to 0, if nums1 at p1, if it is greater than, if nums1 at p1 is greater than, and I will also have a third value here, which should be x, and it will be equals to m plus n. What would be the final answer? M plus n minus 1 x. So if nums1, that is the bigger one, then nums1 at that point x is going to be nums1 at p1 and I have to decrease p1. Likewise, so I'll just copy this, guys. If if we have like p2, if p2 is bigger than nums1, we have to update it with p2, and we have to decrease p2. So if there are like any more elements left, right, if p1 elements are if for as long as p1 is greater than or equals to 0, then I would need this condition to be true. So really some formatting issue. Likewise, if p2 is greater than greater than or equals to 0, then I would need this to be happening inside. And that should be the solution. Let's try. So this is compared to previous one, this is way better memory efficient. So it's a wrong answer. Let's see why. I have to update x. Yeah, I forgot. In either case I have to update x value because we are going to do something or the other. And here as well, x minus minus and x minus minus. I actually don't know if we can update x like inline, but let's try. I don't need this. And minus 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 and delete this and see. Yeah, we can't do this inline. So even though this looks similar to C++, it's not C++, it's Golang, and we are not, from what I remember, we can't do this in an increment or a manner. So let's submit this. Okay, so it seems to be working. I mean, I did not expect it to work because updating it from the end, I was not expecting that. Anyway, it's the solution. Thanks for watching. Let's see some other solutions. 4.8k. Let's see this. This one using traverse from to the end of the, so the entire this is not efficient. You can start with 2 pointers and j initialized to m minus n minus. We will also have another pointer k initialized to m plus n, which will be used to keep track of the position number. We will be placing the large, and then we start iterated from the end of the array and j and compare the elements. At this we will place the large in nums1 at corresponding point I and j. Accordingly, we will continue doing that until we have iterated through all elements. If there are still elements left in nums1, we don't need to do anything because they are already in their correct place. Yeah, this is what I thought of actually, like p1, right? Because nums1, p1 refers to nums1, so if it is still greater than 0, it is all right. Nums1 is already updated until that point, but we have to do for p2. But anyway, so while j greater than or equals to 0. Oh. J greater than I, if I greater than or equals to 0, and set I p1. So you know what this guy did? He basically had this thing, because this is what we are doing here. Instead of like, okay, so we can update our code in such a way that we are only concerned about p2. P2, but we need another check here, so we don't, if it is greater than or equals to 0, and yeah, this should be it. It's a bit more cleaner code, but yeah, it's just preference. Let's submit this. Yeah, we got the solution, but honestly there isn't any much of a difference. Anyway, it's less lines of code, so fewer bugs. Anyway, thank you, bye bye.